Please bust out your calculator. I assume that many of these derivatives you could take by hand if I were focusing on derivative technique. We're not focusing on derivative technique, we're focusing on derivative interpretation. So use your calculator to evaluate today, and it'll save us some time. Would you please find and interpret P prime? Now P prime at t is probably not a calculator problem, it's just a can you take a derivative problem. What is P prime at t, please? 100th t squared minus, don't worry about reducing, minus 1200s t plus 3500s. Are we cool? Now, gosh, did you write yourself a little note? Interpreting a derivative is easier if you use dp dt, not p prime of t. Because dp dt reminds you it's a rate of change, a ratio of change. So in this case, this is change in his distance in school with respect to change in time, dp dt. Change in p, change in time, just kind of getting my feet wet. Now let's go. What does dp dt indicate? In nice, clean words. This is a good participate lesson. And I'm not just talking, Danielle does all the talking. All the left okay. What else? Somebody else. This gives you, P prime represents the, I could think of two different expressions you could do. Speed. Okay, it is speed. Is there going to be a sign component? Will there be places where this is negative? Yes. There will. So if it's negative, is it speed then? Velocity. Okay, so it's, you can say it's velocity at time t, at any time. This rule is for at any time t, in what units? Miles per minute. Okay? The general derivative then looks something like this. A specific derivative should make more reference to the number you calculate. So when you calculate the derivative at 8, just use the numerical derivative function. You don't have to, you could, I guess you could either plug 8 into your derivative rule, or you could just plug the function and take the derivative. But either way, I guess this is the last problem, so I don't know if it's worth putting the derivative or the function in. We could just start by saying 100 of 8 squared minus 1200ths of 8 plus 3500ths is roughly, or unless it comes out exactly, is, it comes out exactly if I remember it. Give me an answer, people. Help a teacher out here. 4.51. Can we all get a yes? Oh, no.
No.
Oh. 0.03. 0.03? And that terminates that too? Okay. All right. Interpret your answer in the context of the problem. When you interpret a derivative, you must refer a specific derivative. Refer to the time. You must interpret the sign. And tell the person, is this increasing or decreasing? Now this is general rules for interpreting a derivative. So for example, in this case, this is change in distance from home with respect to time. So in the velocity sense, we could say at time equal 8, what are the units on time? Minutes. The student is traveling at a velocity or a rate of 0.03 units. What? Miles per minute. Okay? In more general terms that you're going to see later, that's a pretty specific velocity application. But in more general derivative recipe kind of things, you might say the distance from home is increasing at a rate of 0.03 miles per minute. You could also say he's moving away 0.03 miles per minute. On these velocity functions, you could go a lot of good ways. The velocity is probably the best way to go about it. All right. Try this next one on your own. Do that. I'm going to take a 2. Okay. V prime is dv dt. dv dt is change in velocity over time. Change in velocity over time is acceleration. So you have acceleration. And did you get the units correct? Miles per hour per minute. The rate of change in miles per hour per minute. Look at the units carefully. Don't just assume it's miles per hour squared. All right. V prime at 8. I didn't do this one. It's not worth it because it's only an A and B for me. Put it in the calculator. What'd you get for V prime at 8? 17? Did you see? Somebody? 7.28? 10.7. And is that exact? Okay, thank you. 10.7. That's miles per hour per minute. Now interpret. Start with the time. At time equal 8. Units on time equal 8. Minutes or hours? Yeah. At time equal 8 minutes, the student's velocity is... All right, so you could say it's accelerating at 10.7 miles per hour per minute. The AAP, they're a little picky in that you should always interpret the sign. So, is his velocity increasing or decreasing? Yeah, so you could say his acceleration is 10.7 miles per hour per minute. But in terms of really covering your tush, its student's velocity is increasing at a rate of 10.7 miles per hour every minute or per minute. Now this student's blank is increasing or decreasing. That's a general interpretation of the derivative, and even in a non-physicsy sense. So let's talk about a non-physicsy sense. There are lots of different rates of change. It doesn't have to be physics case. So the amount of water in your lake is measured as that function where amount of water is measured in liters and time is in days. Would you please, because this is a multi-part problem, you're going to need this, would you put that function into your calculator? 5,000 t plus 10,000 sine t plus 10,000. Okay, now certainly with numbers that big, we're going to have to change the window. They usually will give you a domain for x or t. In this case, they tell you that the time frame is 0 to 10, if I remember right? Yes. 0 to 10. Okay, now looking at the scale of the number, the Inspire, I'm not used to having the calculator do everything for you. If you have some kind of, does the calculator do some magic window setting for you? What's the button? Is there some kind of, it knows what to do? 4? That's so spoiled. I like to think myself and just say from 0 to, I'll take a guess at 100,000 or something like that. But apparently the calculator knows everything for you. So you said, what's the, it's
an A.
Fit? A? That's so lame. Why can't you just think? Those of us with an 84, we'll just think about it, okay? For thinking?
No, for use the
For Zoom Fit?
yeah, and for like just using the zoom out function, she's like, no, you should make your own window.
You should make sure I'm with her 100%. You're
Even just to zoom out.
too dependent. All right.
You zoom out, so like.
Okay. So tell me, this is the amount, this y represents the amount of water in a lake, and the x represents that time t. So what's happening up to this maximum with respect to the lake? The amount of water is rising. Okay? And then the amount of water is decreasing and rising and decreasing. Okay, so here we go. Getting into the questions then. A prime at t. What is A prime? 5,000 plus 10,000 cosine t plus nothing, right?
Yes.
All right, what does this mean? Think of it as dA dt. Change in amount in liters over change in time in days. So in words, this is a little too heavy symbol. It's the rate at which the amount of water changes in liters per day. Okay? Would you find A prime at 3 using your calculator? Just use the derivative function in your calculator. So go to your home screen. You're going to do derivative after derivative using your calculator. So at 3, and the function, we only have one function this time. We have one function in here. The derivative at 3, I get negative 4,899.924. Do you agree? Okay. Report your answer. A prime at 3 is approximately negative 4,899. Always give me 3 decimals. 0.924. You could go 924 or 925 or 9249. You could give me more than 3 if you like. 9249. All right, that's your answer, your numerical answer to the first part of the question. Now the interpretation. This is change in amount over change in time. Start with the time frame. At time equal 3, what are the units on time?
Days.
Time equal 3 days. What? Change in the amount over change in time. The amount of water increasing, is increasing or decreasing? I'm sorry, I didn't hear you. Is decreasing at a rate of negative or 4,899. I don't need to say negative because the decreasing covers that. 4,899.924 in the units, liters per day.
Could you say increasing and then have it be negative?
You should not, because, increasing at? No. No, don't do that. No. Also, you cannot say change. Change is not specific enough on the AP test to this point for saying the amount is changing at a rate of 4,899, negative 4,000. That's like saying, hey, you interpret this. That's your job, not mine. It's your job to interpret it. You must interpret it. Okay, so they're pretty picky about that. You have to have the number in there. They have to have the decreasing in there. You have to have a reference to the at time 3 in there. If you're missing any of those components, you'll lose 1 out of 9 on the AP free response question this week about. And this is pretty cool. Would you try A of 3? The next question. So let's keep track of the derivative and the amount. Make sure you have it all there. All right, did you get for a numerical value 26,411.200? And you could just say 0.2, that's fine. All right, what does it mean? Okay, at time equal 3 days, total amount of water. In the lake is roughly 26,411.200 liters. Okay, try A prime at 7 on your own. I'm trying to do a little back and forth and make sure you can switch gears. Okay, numerically, did you get 12,539-ish? Okay, interpretation. At t equals 7 days. Anytime you put a number down, it should have units next to it. Such. At time equals 7 days, good. Amount of water is decreasing, increasing, that's what I said, increasing at a rate of 12,539.022 liters per day, right? Okay, so part E, this is also a question you'll see, and it requires a little bit of calculus. Is the amount of water in the lake increasing or decreasing at time 2? Do not do this in a, hey, here's the graph, and see right here, the graph is going down, and that's not justification, okay? A graph is never going to work for justification. Don't say, see, it's going down, it's decreasing. Instead, use the big idea of calculus. something is increasing, something A is increasing if what? A function is increasing if what in calculus? What's positive? Derivative, if its derivative is positive, and decreasing if its derivative is negative. So it is expected that you will take the derivative at the point and interpret the sign with evidence. And do not do it in any other way. Please don't say, I'm going to find the amount at time 2, and then the amount at time 1, then the amount at time 2, and say, see, it went up. No, that's not instantaneous. That's over average change, all right? So it's the derivative at the instant. So you should find the derivative, the rate at which the amount is changing at time 2, at the instant the day is 2, and then interpret and give the answer. All right, so answer the question. Is it increasing or decreasing? Increasing. The amount at time 2 days, always make reference to the time. The amount is increasing because what? A prime at 2 is positive. That's it. You interpret the sign of the derivative to justify increasing or decreasing. Okay? Any questions there? All right. Sometimes you'll have a single amount function. Sometimes you'll have competing functions, like in and out functions. Take a look at this, also a pretty common case. It's usually one or the other on the AP test, not both, but you never know. So you've got this time from 0 to 18 hours, the number of people who have entered a fare up to a certain point in time hours is E of t. And the number of people who have left the fare up to a certain point in time is L of t. You're going to do tons of questions here, so it's worth putting these in your calculator. Please put these in your calculator in F1 and F2. Clear out the other stuff. You don't need it anymore. And put those functions in. I can't remember what that was anymore. What was 95 log of root t plus 1. 95. Okay. Okay. Control G. E2 then. E2. All right, time 0 to 18. All right, so the function of probably grade positive. Enough. Perfect. All right. You get something like that. Oui? Okay. Do you understand why these both have positive slopes? This is the number of people who have entered at any time, cumulatively. Okay? So if E decreased, then that would mean people had unentered, which That's something else leaving. So it's constantly getting bigger. Once somebody's entered, you can't say, all right, now they didn't enter anymore. So this should be constantly getting bigger. As time goes on, more people are leaving. And so they're monotonic, or always increasing, getting bigger for a reason, because you're just accumulating how many people have entered. It's not the rate at which people are entering. It's important to understand it's not the rates, it's the number of people who have entered. Okay. E prime at 7 does not require the chain rule because it's a calculator problem. I expect you to use your calculator to evaluate. So would you find E prime at 7? Make sure you remember which function is which in your calculator. It wouldn't be bad to, on your paper, write a note for yourself. F1 is E, or right above. I might, especially in the AP test, I might say, hey, Corey, this is E1, and this is function 1 and function 2, so you remember. All right, that's for your benefit only. Don't use that in calculator speak in your work for the reader. So E prime at 7 is approximately, or actually equal to, I believe it ended, 5.9375. All right. Now remember, interpreting a derivative is so much easier if you use this notation. So L prime, instead of L prime, I'm going to call it dL dt. So as to remind myself, that's change, difference in, E, not L, sorry, dummy. E is change in enter with change in time. So what does this represent? First step, yes?
Do we have for the dt?
No, it's just a pointer. You don't have to write. Okay, so at time 7, units, hours, what? People are entering the fair. People are entering because he is about entering the fair, if you like. Although I suppose you can do that out. At a rate of? Oh.
You can't have a fraction.
You can have a fraction of time. So, no, do not round. At a rate of 5.9375 people per hour. All right. Yeah, I don't like it.
You have to say whether or not people are increasing or decreasing in that.
Yeah, I that's the thing. I'm not interpreting the sign well. It's not really in there. Entering kind of is implying it, but not good enough. So let's talk about the amount of people entering. Is increasing at a rate of 5.9375 people per hour. Changing the number of entered over change in time. I think you probably will be okay with saying 5.9375 entered per hour at that instant, but yeah, just be safe. Okay. How about L prime at 15? Please find and interpret that. What's that in F2? What time did I say? 15? 15. Of X. Equals 5. Okay. What do you say? At time equal, I hope you refer to the time first and foremost. At time equal 15 hours, what? Amount of people leaving, or the number of people leaving if you like. People leaving is increasing at a rate of 20.085 people per hour. All right. People are leaving, and at that point, the rate at which people are leaving is increasing. Okay, find E prime at 16 minus L prime at 16. Now we're getting into a little more thought. Try that. That's 16. Okay, did you have negative 151.804? Okay, so you would commonly see people say at time equals 16, 51 people per hour are leaving. Yes or no? Why not?
Different people leaving, but 54 are actually leaving and some coming in, so you have to do the total number of people.
All right. This is, if you said this, wouldn't that, if you're just talking about people leaving, isn't that L at 16? And we're not talking about L at 16, we're talking about the difference in the rates. And so, as the man said, it's the difference between the two rates, not the 51 people are leaving. So you'd say something like at time equals 16 hours, the what? The number of people in the fair, not the fair, whatever, is decreasing, interpret the sign, at a rate of 51.804 people per hour. Okay? The amount is decreasing, or the number of people is decreasing, not 51 people are leaving. That would be just L prime at 16. All right. L prime at 8, this is, I thought this was going to be value added, but it's also negative. I was trying to get you one increasing, one decreasing, but that was also decreasing, so scratch that. Go to E. Would you try E? And by E, I mean the first E, please, not the second E. How do you justify increasing or decreasing in calculus? The derivative. You should be talking a derivative when you justify increasing or decreasing. What do you say? Increasing or decreasing? Decreasing. Did you cite, or, doggone it, E prime at 17 minus L prime at 17, the rate at which they're entering versus the rate at which they're leaving, the difference between their rates as the evidence? And did you get negative 145.774? Yes? No? Okay. People per hour. The justification then. There's your evidence. Now make the conclusion. You would say the number of people is decreasing because E prime at, you could actually say one of two ways. E prime at 17 minus L prime at 17 is less than 0. You could also say E prime at 17 is greater or less than? Less than L prime at 17. Either one is fine. The entering, you could calculate the difference between the two and interpret the sign, or you could find each separately and compare the values. Either one would work. All right? Last but not least, do E, and I mean the second E. Who's that? Who was it? Oh, he had a college visit. I'm definitely afraid of people just getting up and leaving.
What'd you do?
What would I do?
Yeah.
I had that happen. Did I tell you that?
No.
I didn't?
No.
Oh, I thought I told this story. First couple of years of the school, people didn't know what it was. They thought it was like a reform school for troublemakers. You know, they didn't. It wasn't. We weren't. Oh, Devil and smart kids. It was just. Hey, there's this other school. In case you got kicked out of your school, you could go to Devil. So we had this weird mixture of people that were super motivated and people that were criminals. And I had this kid. I was teaching algebra 2. I was just doing my thing, and he threw his book down and said, and left. He just left, and I never saw him again.
Look him up on Facebook.
Really troubled kid. What?
Look him up on
I
Facebook.
don't even remember what it was. 20 years ago. But
Well,
I mean, it was my first year teaching. I didn't know what the heck I was doing anyway. And I just, I didn't know what to do. Now, we all really wanted to do that.
Rick, there's probably a yearbook box in the library. You didn't find that guy.
Oh, I should look him up. But he never, yeah, I don't know. But yeah, he's a real troubled kid. I hope he worked it out. Man, it's just just a basic algebra 2 problem. It's not like that.
Wouldn't it be hilarious if you were a millionaire? That would
It
like,
wouldn't surprise me. That's how the world works. What did you get for 8, E of 8, negative 263? This actually is kind of a crazy answer. Did you get something like negative 263-ish? Okay, negative 263.568. All right, what does this imply then? This isn't so much at an instant as a cumulative effect. What do E and L represent? How many people have entered and left up to that point? Okay, so up to time equal 18, or if you like, from time equals 0 to time equal 18 hours. What? This is the number of people who have entered. This is the number of people who have left. So the difference is the change in the number of people. The number of people.
263 people can't be out there.
Yeah. Now I assume at time 0 there were some people there. So it's not like, there's negativity in the existence of people. Yeah, assume, you don't know what time reference is. Maybe we just started talking about the counting the people after the fair had already been open. So
I hope so.
probably not a great
I didn't
idea.
actually,
18
like,
hours is a long day for a fair.
Yeah. Number of people.
that's why
Number of
everyone
people
left. They're like, I quit, these are
Yeah,
like, working
exactly.
conditions.
Decreased by 264-ish. Oh, I never rounded. 264-ish, approximately 264 people. All right. That's not a derivative, so it's not d dt or d people d time. It's just people. Okay? And so that's why the whole number. Okay, switching gears, totally unrelated, but calculus idea, more of a physicsy idea. Sometimes, in terms of force, you want to counteract a tangent force with a perpendicular force. That perpendicular force is called the normal, or orthogonal in terms of vectors, but which is one of my favorite words, orthogonal. A normal line is perpendicular to the tangent. So you're going to be asked to find a normal line, and it's 90% overlap with the tangent line work. Just like tangent line, it's point, slope. The only caveat is the slope, first find the tangent slope, then perpendicular slope is opposite reciprocal, right? So it's got that one little extra step in there, and other than that, it's pretty much the same way. So let's say we do this here example. Find the equation of the normal line 2, 3 sine squared at pi over 6, no calculus. The points, obviously x equals pi over 6, but we need the y of that. What is 3 sine? I'm going to rewrite this as pi over 6 all squared. That's just what it means. What's sine of pi over 6? 1/2, and squared times 3, 3/4. So the point that we must pass through or be normal to is pi over 6, 3/4. Now the slope. The slope, let's start with the derivative and then we'll do the perpendicular. What is the derivative of f? Again, keeping in mind that that squared notation really means the whole sine function is squared. 6 sine of x, then cosine of x. Do you agree that's a chain rule problem? All right? Being careful not to bleed the general derivative into the specific, let's in the next step say, all right, the derivative at pi over 6 is 6, what's sine of pi over 6? Again, 1/2, and cosine? Root 3 over 2. So simplified, this is something like 3 root 3 over 2. Wait. Now it's that one extra step. The perpendicular slope for the normal line is opposite reciprocal. You do not have to rationalize. So the opposite reciprocal in a simple form is -2 over 3 root 3. Wait. Negative, right?
No, I just.
Why did I?
Is it opposite reciprocal?
Yes.
Okay.
So, yes. I mean, sorry, I didn't cover that. Do you agree that if I had a slope that was flat, like 1 over 2, the perpendicular would be steep, so 2 over 1. So that's why they're reciprocal. But also, if you have positive slope to be perpendicular, it'd have to be negative. So always opposites are reciprocal. Okay? So the point slope form then for the normal line would be y minus 3/4 equals -2 over 3 root 3 x minus. That's the normal line. And boom, you're done. Okay? Pretty much the same as tangent line, just with the one little extra step. All right, I want set 37 due at the very least today, so let me talk about any questions you have on 37. I don't remember where we're at. Did you already turn in 37? No. All right, 37 questions if you have them. And we're going to get caught up this week. I'll start putting the hard ones at least online so you can look at any super challenging ones. Maybe I'll do 5 to 10 per set for the harder ones. Questions on 37 if you haven't.
The replacement for 24.
Replacement for 24. Okie dokie. Yes. Anything else while we're here? Oh yes, you're hoping to raise your hand. That's crazy.
Accidentally turned it in already. So
Do you want it or you want it? Huh? No. Okay. Good. Is it?
Yeah.
Okay. News to me. All right, 23. Okay. Let me know if you have something else to add. 24 is, I feel super ugly, but I actually am going to try and do this without a calculator. Oh, it says actually, never mind. Use your calculator answer. I feel like you could do this without a calculator. Whatever. At rest. To find at rest, you want to find where the velocity is 0, yes? Okay. Now you could then plug this into your calculator, although it's not bad to solve actually, but we'll plug it in our calculator. Oh, shoot. E to the root t x sine x minus x1. Boom. Okay, setting the window to 0 to 10. Boom. 0. Okay. All right. So, do you just need answers, or do you want to talk about this? Sorry.
Can I have Nancy's and then if I don't know?
Sure. Okay. So I found that this is velocity equals 0 at. I did this by hand, so my answers are clean. But pi, 2 pi, and 3 pi. So you should have obviously 3.141, 6.282, 9.4 stuff.
Yeah.
2, 3. Okay. So we're good on A. Backwards. Backward implies that velocity is negative. Velocity is negative on, and so for that, it was between pi and 2 pi, and between 3 pi and 10. Be careful with your endpoints here. Pi to 2 pi, is it negative at the endpoints or 0 at the endpoints? 0. So do not include there. What about 3 pi and 10? Is it negative at 3 pi or 0? 0. But is it negative at 10?
Yeah.
It is. So you should have inclusive of 10. Okay. The average. Okay. So this is actually a typo here. Average velocity. That's your honors. Did you guys do average value of a function last year?
Yeah.
Okay. So you might have been able to do this if you're a Calc honors person, but otherwise, it's probably not doable. What I intended for D was average acceleration. So let's change it to average acceleration. Average acceleration is change in velocity over change in time over an interval. So it's not a derivative. It's a change over an interval. So I'm looking at something like v at 10 minus v at 0.
What up? Free ride.
No, I need
You don't like announcements?
To the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, so that's
Attention ninth graders, today is the day to complete your annual service project of cleaning up the teeth. Sign up for South Hour with one of your teachers. You'll then be released via announcement.
What do you think?
We'll
Good?
then be at the
Okay.
base of the hill.
All right.
We're done.
23.
Smith and Mr. Cable.
Tickets for March 20th Day go on sale today during Cold Luncheon. Reserve seats go for $8 or you can pay $10 at the door.
The Direct Teacher Conferences are tomorrow, Wednesday, October 4th, from 5 to 7:30 p.m. and Thursday from 3 to 5:30 p.m.
Live Touch will be here this Thursday, October 6th for picture retake in the auditorium.
Check out these colleges and counseling today at 11:30 a.m. Case Western Reserve during South Hour, Williams College from Williamstown, Massachusetts, and a virtual visit with Massachusetts Institute of Technology. If you want to attend a college visit during South Hour, sign up for Counseling South Hour.
Tomorrow, 7 amazing colleges will be visiting with interested students. Stop by at 10 a.m. to visit Westmont College, at 11 a.m. Biola University, 12:45 p.m. Seattle Pacific University, 1 p.m. Dallas Baptist University, 1:15 p.m. Azusa Pacific University, and during 7th hour Boston University and Colorado College.
Hi, Jags. Want to be featured in the yearbook? Send in your funny Snapchats and Instagram screenshots to yearbook.jags@gmail.com.
Senior high students, seniors, do you need a letter of recommendation from Ms. Harrington or Mr. Watson for your college application? If so, you can come to counseling to make an appointment for a 30-minute interview. See your counselor at least 2 weeks minimum so they can write a stellar recommendation for you. Do not wait until the last minute. Also, check your college application deadlines as some have October 15th as early action.
Superb Jags. Our 7-4 boys soccer team defeated Valor 4-0 on the Eagles home field last night. Take that. Oliver Holzer scored twice while Bert Lee and Will Thompson each contributed a goal. Assists were provided by Alan Lee, Kyle Boyd, and Holzer. Nate Hester had 6 saves and goals. Next up is a trip to Littleton High School this Wednesday at 7 p.m. Go Jags!
Tonight at 6:30, come watch your Dublin Jack volleyball team in the gym. Wear a team. That's all your announcements. Have a great day.
Something like that. Lee? Use your calculator to check. Other questions on 73-7? Make sure I get 37 today.
My dad's that's why I was like,
Okay.
Today, and it's my alarm. And I